Okay, so section 1.7 is on linear inequalities and absolute value inequalities. So you should have seen both of these before, and inequalities are things that y'all started working on in like middle school. So I'm going to try to keep it short and sweet, but let me know if you need help with anything, if you have questions or anything like that. All right, so first of all, a linear inequality is like a linear equation. It just has the less than or greater than. So you're going to solve it basically the same. There's just one difference that you have to keep in mind. If you have to multiply or divide by a negative while you're solving, you have to remember to flip that inequality symbol over. Some other things that are on this slide that will help is that anytime that you solve an inequality, you don't have one answer. You get things like x is less than 5. So it's all of the numbers less than 5, like all of the pretty numbers, all of the ugly numbers. So the easiest way to show your answer, since it's not just one specific number, is to graph it. Or if you don't graph, you can write your answer in what we call interval notation. So if you have something like, just for an example, if I have something like x is less than 5. So that's the less than symbol. That's what that next word right there means, or this next little column. This is telling you what it should look like on a number line. So on a number line at the number 5, I would have, because it's a less than without the equal to, an open circle. And since it says less than, I would shade towards smaller numbers, so to the left. For interval notation, we use a parenthesis if there is a less than or a greater than, if there's not an equal to. Anytime you would use an open circle, you're going to use a parenthesis for your interval notation. So if I turned this into interval notation, I'm saying I want to go all the way to the left on the number line, which would be negative infinity, which always gets a parenthesis because it's not a number. And I'm going to go all the way up to 5, and I'm going to stop. And I use the parenthesis to say stop at 5, don't include 5. If this had an equal to, like if it was this guy, if it said x is less than or equal to 5, then when I did my graph, it would be a closed circle telling the world that 5 is an okay value. And interval notation tells the world that 5 is a good answer by using a bracket. All right, so less than and greater than are going to have open circles, and you use parentheses with your interval notation. If you have the less than or equal to symbol or the greater than or equal to symbol, that's using closed circles, which would be brackets. All right, so that'll work itself out as we go along through the lesson. All right, so the first thing we're going to do is just, can you solve these inequalities, graph your solution sets, and then write it in interval notation. All right, so for this one, we want x by itself, so we're going to add 5. I'm going to go ahead and apologize in advance. I'm making this video at home because I'm helping with ACT stuff during the day, like during my planning period. And so this writing tablet that I have at home is difficult for me to use. So it's going to be a hot mess. My handwriting, I apologize. Okay, so we add 5 to both sides. Then we divide by 7 on both sides. And we get that x is greater than 3. All right, so on a number line, we're going to say here's 3. Now, if you want to be extra meticulous, or if you've had a teacher in the past that made you and you just feel like you have to, put more numbers on your number line. I'm going to assume that you know that we're going to go 2, 1, 0, -1, yada, 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 and 4, 5, 6, 7, 8. I'm a little lazy. I don't write all the numbers down. I'm not going to expect you to. So this is good enough for me. All right, so this is going to be an open circle. And we're going to go towards bigger numbers, greater than. So we're going to shade this way. So my tip, if you struggle with which way do I shade, as long as your variable comes first, that thing points the way you should shade. It's pointing to the right. So I shade to the right. This says x is bigger than 3 because the alligator is eating the bigger number. Bigger numbers are to the right of 3. All right, so interval notation. Some people have to look at the graph to get it. And if that's you, then that's fine. If you look at this, we start at 3 and we go forever, which means we go to infinity. It's an open circle, so you need a parenthesis. Infinity is not something you can actually be, so you need a parenthesis there. Infinity always gets a parenthesis because brackets are for numbers that are actual solutions, and infinity is not an actual number. So you can't be infinity. So you can't have a bracket. All right, number 2. All right, so first step is we're going to distribute this -3. All right, then we can combine like terms. So 5 minus 6 is -1. All right, now we want to add 1. I'm running out of room, so I'm not going to show every single step like I did over here. I'm going to add 1 on both sides. So I get -3x. Is it greater than or equal to 9? Then we're going to divide by 3. I am going to write that step down because I need you to see I'm dividing by a negative. So I'm going to flip that inequality symbol. And the easiest way to explain that is if you think about a number line and how numbers work. If I'm on this side of 0, my numbers are getting bigger as I move to the right. Well, going this way, I'm technically getting smaller, but do you see how it's actually the numbers look like they're getting bigger as you move to the left? So when I flip from one side to the other of the number line, my inequality symbol has to flip over for things to stay true. All right, so back to the problem at hand. If we're going to make a number line for this guy, I can just say -3. And since there's an equal to, -3 is an option for a solution, so closed circle. And we are dealing with less than, so we're going to shade to the left. All right, a couple more examples. If you're feeling confident, you can pause the video and see how you do on your own. These two are both a little bit different, though. If you want to just follow along, that's cool too. All right, so here we have variables on both sides. So you can subtract 4x and go this way. You can subtract 5x and come this way. It doesn't really matter which way you go. I like to keep the x on the left side. That way I can remember that I can just shade the way that my symbol points. But honestly, it does not matter. All right, so if we subtract 5x on both sides, then we have -x minus 9 less than 3. Almost wrote that 5x, but then I was like, duh, I just subtracted that. Okay, so now we're going to add 9. So add 9, 9 plus 3 is 12. All right, I want to know what x is, not what -x is. So I have to divide by -1 to get rid of that negative sign. And when you divide by negative, remember that that symbol flips over. All right, so now we're ready to make our number line. I think I forgot my interval notation on number 2. Did I or did I not? I can't remember. Let's finish this one and we'll go check. All right, so open circle. And greater than is this way. All right, so we are starting at -12. And we are going to infinity. And it's an open circle, so we use a parenthesis. All right, what did I do up here? I did not do interval notation up here. All right, so back to this one for interval notation. This is pointing to the left. So we're starting with -infinity. And we're going to -3, and we get to include him because it's a closed circle. There was an equal to. Okay, so number 3. First thing is parentheses have to go, so we're going to distribute that too. All right, now again, you got variables on both sides, and actually, if you notice, you see how they match. So this is going to be an infinitely many or a no solution situation. So if we subtract 2x on both sides to try to get our variables on the same side, you notice that that cancels and that cancels. So you're left with 8 is less than or equal to 3. All right, when your variable disappears, remember that it's either no solution or infinitely many. And whether you have a true or a false statement is what tells you which one you have. So you got to stop and think. This says 8 is less than or equal to 3. So is that true? Is 8 smaller than 3? That is not true. This is a false statement. which means there is no solution. So if I tried to graph this, all I would do is leave an empty number line because there are no solutions. There's nothing to shade in. All right, so while we're on the topic, without working an entire another problem, let's say we worked a problem and it worked out to be 8 is greater than 3. Well, 8 is bigger than 3. So this is true, which means it would be infinite solutions. There goes the ugly handwriting. Infinite solutions. If you have infinite solutions, that means all numbers are solutions. So when it came time to graph, you would shade the entire number line. All right, and again, like shading, I just kind of scribble because it's easier with what I'm doing. If that's what you do to shade for yourself, that's fine with me. You can make it look neater if you want. All right, so next, compound inequalities. Again, that's not something that is new to you. We did it in Algebra 1. I'm pretty sure y'all probably handled them in middle school too. I can't remember if we cover them in Algebra 2 anymore, but I know they were covered in Algebra 1. All right, so compound inequality is just when you put two inequalities together and you can join them by the word and or the word or. So we'll talk more about the or ones when we get into absolute value, because absolute value turns into a compound inequality and you'll see some ands and some ors. But with the ands, if it's not an absolute value situation, then they tend to take two inequalities joined by and merge them into one inequality with three parts. And those confuse people. So that we're going to do a couple of examples of those. So if you look, if this is my compound inequality, I'm saying that 2x plus 1 is more than negative 3. So negative 3 is less than 2x plus 1. And 2x plus 1 is less than or equal to 5. Well, I can take that and smush it. Instead of being redundant and saying this part twice, I can just write it as one long inequality. And you see how it has two symbols, and it gives it 1, 2, 3 pieces. So the way that we're going to work these is we want this x by itself in the middle. But since there are 3 sides to this problem, if I do something in the middle, I'm going to have to do it on both ends. All right, so number 5 is that same inequality. And again, I want x by itself in the middle. So I'm going to subtract 1. If I do that here, I've got to do it on this end and on this end. So this will become negative 4 is less than 2x, which is less than or equal to positive 4. All right, so now, again, I want 2x by itself here. So I have to divide by 2 to accomplish having just an x there, which means I got to divide by 2 on both ends. So this is negative 2. And this is positive 2. So on a number line, I just say I know negative 2 goes down here, positive 2 goes here. This is saying open circle at negative 2, close circle at positive 2, and shade in between. All right, so interval notation is saying let's just trap it in this little hole. So parenthesis negative 2, because it's an open circle, up to 2 with a bracket. So these two things are saying the same thing. Every number between negative 2 and up to and including positive 2 is a solution to that inequality. All right, so number 6. We're going to add 5 in the middle because we want to try to whittle it down to just be an x. So getting rid of that minus 5 is our first job. And if we add it in the middle, we got to add it on both ends. All right, then we want to divide by 3 in the middle. So we've got to divide by 3 on both ends. All right, so then we can do our number line. And this one is going to go from 2 to 6. We include 2, and we go up to 6, but we stop just short. So I can be 5.999999. I just can't be 6. So my interval notation is going to be a bracket on the 2 up to 6, but don't include it. So a parenthesis. All right. So next we have absolute value. So absolute value inequalities, just like absolute value equations, you have to make two separate problems because of the definition of absolute value. There's no magic mathematical operation that's the inverse of absolute value like there is for addition and subtraction and multiplication and division. So the way that we handle absolute value is make two problems. All right, so to make sure you're understanding what this is talking about, absolute value means distance. So this is saying I want the distance from 0 to be less than 3 units. Well, if I go 1, 2, 3, I've been 3 units. So all of these numbers are less than 3 units. If I go 1, 2, 3 this way, all of these numbers are less than 3 units. So I'm saying that I want to stay between -3 and 3. I want x to fall between -3 and 3. So if I wrote this as an and inequality separated, it would just be that x is less than 3 and I'm trying to make them work. X is greater than -3. If you take this piece right here says that x is more than -3, and this piece right here says x is less than 3. So this guy gets written like this, and the absolute value is gone. All right, so for this one, this is saying I want the distance from 0 to be more than 3 units. So again, here's 0, 1, 2, 3. I'm 3 units away, and I want to be more than that, so I'm going to go out here. All right, so go 1, 2, 3 units this way. I want to be more than that, so I'm going to go out here. So this is saying that I want to be less than -3. This is saying I want to be greater than 3. And that has to be an or, not an and, because they point in different directions and I can't do both of them at one time. All right, so anytime you solve an absolute value and you graph, you're going to get something that looks like this or something that looks like this. This is always an and, this is always an or. So at the beginning, if you don't immediately remember that if it starts out less than, it becomes an and. If it starts out greater than, when I rewrite it, it becomes an or. Once you've done your graph, you'll remember because your picture is going to be your clue. All right, so working a few examples of these. All right, so first of all, absolute value is all by itself here, so I can go ahead and split. So the first time I write it, all I'm doing is losing the symbols. All right, so it's less than, so it's an and inequality. I wish I could write. Okay, so I can have this and I have this. The junk in the absolute value stays the same. The symbol switches and the sign of the number changes. So again, I changed it. I switched to the other side of 0. So I flipped that inequality symbol over. All right, so then I just solve both of those and graph them on the same number line. So we add 2, and we get that x is less than none. Here we add 2, and we get that x is greater than -5. All right, so on a number line, stop and think before you just write your numbers down. -5 comes first on the number line, so we're going to put -5 here. I'm trying hard. Okay, here we go. -5 and 9 on this side. All right, so at the 9, we want to have an open circle and shade smaller. At the -5, we want an open circle and shade bigger. So those are going to overlap in between those two numbers. So I go from -5 to 9 as my interval notation. Okay, so number 8. Absolute value has to be by itself before you can split, just like when you're solving an equation. So we're going to add the 5 on both sides. So we have 2, absolute value x plus 3 is greater than or equal to what, 14? Then we divide by that 2 to get rid of it. Because remember, you cannot distribute into absolute value. So we have absolute value of x plus 3 is greater than or equal to 7. Now that the absolute value is by itself, you can make your two problems. So you write it down exactly the same, just lose the bars. It's a greater than at the point that I split, so we make it an or. And then we switch the symbol and make it a negative. All right, so working this one, subtract 3. X is greater than or equal to 4. Working this one, subtract 3. X is less than or equal to negative 10. All right, so on a number line, again, pay attention to your numbers. Negative 10 comes before 4. Both of them are going to get a closed circle. 4 you shade greater. Negative 10 you shade less. And it was an or, so them pointing in opposite directions is fine because you can be something or something else that has nothing in common, but you can't do an and when they point like that. All right, so interval notation. These get a little hairy. Looking at our picture, we have negative infinity up to negative 10 and include it. Then we have this big gap. Well, the symbol we use for a big gap is that union symbol we learned a while back, because now we're saying unite these two things that don't have anything in common. Pick back up at 4 and go to infinity. All right. One more example of these, and then we're going to talk about just some shading stuff. Okay, so here we go. We are going to subtract 20. All right, then we have to divide by negative 3. And it's been a few minutes since we did this, but remember when you divide by negative, that inequality symbol flips over. So switch it to less than. All right, so now we have the absolute value by itself. So we're going to make two problems. At the point where we're splitting, it's a less than, so it's going to be an and. So we have 5x minus 2 is less than 13. And then and 5x minus 2 is greater than negative 13. All right, so we're going to add 2. Divide by 5. And we have x is less than 3. Here we're going to add 2. Divide by 5. And we realize that the world does not work off of nice, pretty numbers like we've had so far. So a negative 11/5. Let's see, 5 goes into 11 twice with 1 left over. So negative 2 and 1/5. You can type that in your calculator. You get negative 2.2. That's okay to use that as well. All right, so on a number line, we have negative 2 and a 5th. And then 3. All right, both of those are going to get an open circle. We want to be smaller than 3 and bigger than negative 2 and a 5th, so we're going to fall in between. And that means our interval notation is going to be parenthesis, negative 2 and a 5th, comma 3, parenthesis. All right, so our last slide is just, can you understand interval notation? We've worked a lot so far on writing our answers in interval notation, but can you read interval notation so that you can graph it and come up with a new solution? All right, so here we go. Let's see if I can color code things. So if I, on this number line, I know I'm dealing with a 5, a 1, an 8. So I'm going to put those numbers in the order that they would fall. So 1 would be here, and then we could say like 5 here, and then 8 here. Again, I'm not looking for perfection, but make some sense out of what you've got going on. All right, so if I'm going to graph this guy right here, that's saying an open circle at 5, and we're going towards a negative infinity. Okay, if I'm going to graph this guy right here, it's a closed circle at 1, shade up to 8 with an open circle. All right, so if I'm going to do these together with that union symbol, union means that I'm combining them with an or. So remember, union was when I put two groups together and took all of the pieces of both of them. So I want everybody's everything. So anything that's shaded any color. So ultimately, that means that I want to start at 8 and I want everything smaller than 8. So if I wrote my solution set in interval notation, it would be negative infinity up to 8 with a parenthesis. This is the answer that we would be looking for. All right, number 11. Again, we have what numbers? 2 and 4. All right, so for the first one, we have bracket towards infinity. Bracket at 2 and go towards infinity. For the second one, we have parenthesis at 4 and go towards infinity. All right, so then we stop and say, okay, so we're doing a union, so we can just merge it all together. Everybody's everything. So you just really go with the longer one, honestly. It's the easiest way to put it. So we go this way. So we would say go from 2 to infinity and bracket on the 2. All right, number 12. We want negative 4, negative 2, 0, 1. All right, so this guy says open circle at negative 4 to open circle at 0. This one says close circle at negative 2 to close circle at 1. All right, so now when we try to combine, our symbol has flipped over. We now have an and. We have a intersection. So I want to know when those two things overlap, when I can say that I'm both of them. So this that's just red is a no. This little piece that's just blue is a no. It's got to be right here where it's red and blue. So we're going to go close circle to open circle right there. So we'll just go from negative 2 to 0. All right. Again, if you have questions about anything, please send me an email. I'm happy to help. This is the assignment. If you need help with a problem on that, again, send me an email and I'll be happy to work it out for you and send it back to you.